Swayam Prabha. Digital India. Educated India.
Welcome back to this class. Today we are going to start a totally new topic. For the last several lectures we've been focusing on solid waste coming out from the municipalities, industrial solid waste coming out from industrial areas. But all of this waste has been in the form of solids with some moisture. We are now going to start a new topic on slurry type of waste. Slurry type of waste means that you have waste which is mixed with a lot of water and comes to the waste disposal site in a pipeline. All the waste which we have dealt with earlier comes to the waste disposal site. How does it come to the waste disposal site? In landfills, how does the waste reach the site? In trucks. Anything else? In trains, anything else? In ships and barges? Most of it comes in trucks, but do remember, waste is transported even in trains, in dedicated tracks, and waste is transported even over water, where the options are that the landfill is on the other side of a water body. In one of the US sites, the landfill is on an island. The waste has to go through water to reach the landfill. It's supposed to be the biggest landfill. And when the Twin Towers fell down, where did all the waste go? What do you think happened to the waste of the Twin Towers? Vanished? No. So it went to a landfill, right? And it was transported by various means to that landfill. However, that waste could not have been transported in the form of a slurry. Slurry disposal is for waste which is finer than sand, silt sized, sandy silt, silty sand, which can be mixed with water and then can be pumped. Can you mix gravel with water and pump it? No. You can mix gravel with cement and pump it in the form of a paste. You have concrete pumps. Coarse aggregate you can mix in a paste. But we are talking of lean slurry which can be mixed with water, waste which can be mixed with water and comes in the form of a slurry. So this next half an hour or more, we are just going to get a flavor of the slurry deposited waste and see what are the aspects of disposal which are important for us. So what kind of waste comes in the form of a slurry? Much of it in India is the ash coming out of burning of coal. And all of you have burnt wood or coal and you have felt the ash. Is it very coarse particles? No, it is something which will just fly and it's fine particles. So coal ash is one. The second major material is mine tailings. Coal ash is coming out after burning of coal. Mine tailings are coming out after crushing of rock or crushing of ore. So what happens is you want to take out iron or copper or lead or zinc. You dig deep down to get to the ore. And don't think that huge blocks of iron come out or huge blocks of gold come out like here's your gold. It doesn't come out like that. It is embedded in small proportions in the rock. To be able to extract it, you have to crush the rock and then process it by several steps to be able to take away the metal or take away the material which are of value to you. In this process of crushing, the finer you crush it, the better it is, because more is the material which is released. If I take a rock sample and crush it into 4 pieces, will the gold start coming out of it? No. But I crush it into as fine as talcum powder, then it's possible that some of the metals would be released. You have to still go through a lot of processing, chemical and physical, to get the extract. But you are left with the parent rock in its crushed form, which has gone through chemical processing, right? So if you are doing gold extraction or if you are doing lead extraction, you would have crushed this and you would have sent it through various processes where additional chemicals would have been added. In the end, what is left is this rock powder with these chemicals in a high water content. You mix it with water and it comes to you in the form of slurry. So at the tail end of a mine, it's called mine tailings slurry, and there are other types of slurries with which you deal. So we're going to look at some slurry waste disposal sites and how do they look like. So this is a huge area in one of the adjacent to one of the thermal power stations. This is coal ash. This is water. The ash is coming in these pipelines and being deposited here. And just to get an idea, maybe this is 2 kilometers by 1 kilometer in size. So on 3 sides are hills. On one side is an embankment. Just like you create a water reservoir, you have created a pond in which the slurry will be deposited. The technique is very simple. You deposit your slurry coming out of a pipeline in a pond. Within a few hours, the particles will settle down and clean water will be at the top. You take it back for transporting more material. So the water and slurry, the water used for making slurry is just a medium for transporting these particles. And it's good because you can pump it. It's good. If you were to try and send this material on a truck, it would tend to fly out, so you would have to containerize each truck. This operation can go continuously because the slurry pipelines can work 24/7 as long as the plant is working. So we can see this embankment. There's a water decanting structure because the water has to go back. This is the embankment that you can see. This is the decanting structure. This water falls down into this well and comes out on the downstream side. So this is being taken back again in these pipelines for back to the thermal station for recirculation. Let's look at another ash pond. This is an old small ash pond in Delhi, not 2 kilometers by 2 kilometers, much smaller size. But again, a lot of water being used. That's the inflow slurry pipeline. You can see that grayish water coming in. Here it was not a closed system. Here the overflow water is allowed to overflow through the weir and it goes into Yamuna. So if your settlement time is adequate, then clear water will go through. But if your settlement time is not adequate, what will happen? Milky water will go through. So at the time when this pond was operational, this ash is whitish grey. You could walk along the river Yamuna and you could see that in that portion there was a milky water which was going in. That's the way the layers of ash as they are deposited. If you excavate it, you can see horizontal layers of fine and coarse ash as it is hydraulically settling. First the coarse particles will settle, then the fine. Then the next load will come, coarse and fine. So you can see horizontal, very thin horizontal layering. This is an ash pond at Visakhapatnam. It's almost like a lake, a 2 kilometers by 1 kilometer lake. And on one end this is full, that's where the slurry is going. And you can use the ash for purposes of infrastructure development. We will do this later. Here it is being rolled like a soil using a roller. Question that's in your mind is this material safe? Is it hazardous? Is it having some heavy metals? Can it cause problems? That is something which we will address. There's adequate information now coming in from the US that coal ash is causing contamination of the groundwater by a very few very rare elements like vanadium and boron. Very mild, but definitely elevated. Earlier, most of the time, this has been treated as not being chemically harmful, and whether that is true for Indian ash or not is something which has not yet been corroborated. So now, in America, all the ash ponds have to have liners like landfills. In America, just 2016, the US EPA has brought out the coal combustion residuals rules, in which liners have become a big issue. Let's look at another ash pond at Panipat. Here are the slurry. Lean slurry, I think 10 times the water to 1 time the solids. This is ash pond. That's your thermal power station. This is a huge amount of ash. You can see if it is dry, it's going to fly. It's called fly ash. It gives you dust emissions. So you have to keep it wet, or you have to keep it submerged if you don't want dust emissions from these. So in dry summer months, these can create a problem. Here also they are trying to use the roller for compaction. Yet another ash pond at Delhi. I think this is the Badarpur ash pond. And slurry inflow. They are growing greenery on it so that ash does not fly. Embankment, so the ash is being deposited here. That is the water decanting structure. So as you can see, the water comes into, this is a well, and the water is flowing in. Is this clear water? Not clear, because very fine particles of ash take about 12 hours plus to settle. So if the retention time is not 12 hours, then if the water starts to overflow before that, then the fines will go out. And the limits for discharge to rivers is about 50 ppm. So we have to meet the 50 ppm now. Once this is full, they are growing some vegetation on it so that you get a green look, and the fugitive dust emissions are minimal. That's the thermal power station. So far we looked at coal ash. So we have about 80 to 100 thermal power stations, each producing millions of tons of ash. There's a lot of pressure on reutilizing ash, and ash being silica, tendency to use it in earthworks, or even better, use the ash in cement because it has some pozzolanic properties, and to make bricks. Anything which requires material. I mean, when you make a building, you need bricks, you need concrete, you need aggregate, coarse, fine aggregate. All these materials are dug up from Mother Earth. But now if you have got a waste material, in building blocks at least the ash is held now. In earthworks, ash is not held. It will undergo leaching. In building blocks, you'll have a burnt brick, or you'll have, in the cement, the ash will be confined. Let's look at tailings ponds. This is a dam behind which the tailings are being stored. This dam is made up of rock waste which is coming out from the mining operations. And these are just like ash. You could see a whitish grey material. This is the whitish grey material of the tailings pond. And again here, it's a cross valley impoundment, so you can see hills on all sides, right? And this was the embankment across the hill. So it could have been a water reservoir or a water dam. See? And when it is full, then you try and grow some vegetation on it to give it a green cover. This is yet another tailings pond. As you can see, these are the tailings. This is the water which has accumulated. This is the embankment. That's the slurry pipeline which is coming here. It's being dropped at the side of the hill. It falls down into the reservoir. And this is gradual filling up of the reservoir with the tailings material. This is the second pond, tailings pond. Similarly, this is at the third site, again in Rajasthan. Looks like a lake, wonderful lake. This is also a tailings pond. This is the embankment, must be about 10 meters high. You can see the pipeline, that's the slurry pipeline. Slurry coming in, this is the deposited slurry, that's the lake. So the water is ponding there. They are holding excess water. And this is almost full. Now this embankment is full. Still slurry is coming in. Eventually they'll have to raise the height of this embankment to fill in more material because the plant is continuing 24/7. This is the highest tailings pond of the country, now no longer operational though, a 100-meter high dam. These are iron tailings in the form of a slurry. This is a huge dam built like a, again see some hills here. So wherever you can have a hilly area around you, you can just make embankment on one side. But if you have got plain ground, then what? You have to make the embankment on all the four sides to be able to make the pond so that it can settle down and sort of allow the solids to settle down and allow decanting of supernatant water. And just we will discuss this later. This is the rock toe of this dam. So the dam is about 80 to 100 meters high. The rock toe is 10 meters high. The rock toe is 10 meters high. Important thing for you to remember is these slurries are full of water. So you have to design these dams as if they are water reservoirs. And you will have seepage through this and the water will come out on the downstream portion. This is a photograph of, I have not visited this, but in one of the magazines several years ago this was reported. This is the tailings pond for a uranium tailings in Bihar. It was affecting the local population. It's not only mine tailings which may come out in the form of a slurry. Here is a process called mineral extraction which releases a slurry known as jarosite. And have a look at this. This is a jarosite pond. No water, you can just see some yellowish material. It's a hazardous waste, by the way. The waste is coming in the form of a slurry. So here also you can see just some accumulation of water there which is being decanted. So this is also hazardous waste being disposed in the form of a slurry. It has a liner and it will have a cover. But when you look at this whole area, you see that it's green outside and the vegetation is getting affected by the constituents of the slurry water and it is drying it out. Slurry ponds appear to be very simple to make, but you have lots of distress in them. Occasionally you will find it will breach because they are not well maintained. So I'll just give you some shots. That is an ash pond which has breached, this embankment has broken and material has flown out. You can see this breach. Ash is behind this, it has flown out for a few hundred meters. Because once the slurry starts to come out, it flows like water. It doesn't stop at 10 meters or 20 meters. It's not a thick paste. And just to give you an idea how far this slurry has come. Can you see that? And embankment failures. And you can see this is spread over here. There's slurry water and this embankment has failed. Some more shots. This was when I talked about embankment. You can see that this embankment is also undergoing distress. Can you see these erosion gullies? This is stage 1 of the embankment. This horizontal line you can see, this is the crest of the first embankment. Okay? And this is now the second embankment. Now the problem is the joint between the two embankments has not been designed properly. So what is happening? This is becoming a seepage plain. Horizontal permeability at the crest of the old embankment is high and water flows out and is eroding this embankment. And this required remedial measures so that this should, once this gives away, the whole mine tailings will come out. Here's a better shot about these erosion gullies. And here is the road on which we are standing. And here you can see, you stand on the top of the second raising, and this is the original crest, you can see it's wet. So, and it leads to seepage of water. And some distress already beginning to show up at that site. This is another location where there was distress to the embankment and a nearby canal due to an ash pond being nearby. So what I'm trying to say is that when you deal with slurry ponds, once the slurry dries, it is just powder. So it doesn't look very challenging. After all, you are just storing powder behind a embankment. Doesn't do. But if you don't treat it like a water reservoir, and especially when the heights of these embankments are now going 20, 25, these are incrementally raised. You'll make a small embankment, fill it up, then make the next height. If you don't design them like water reservoirs, water is very difficult to handle, remember that. So you always feel, no, pani kam kar denge, dur rakhenge, we'll keep it away from the embankment towards the center. It doesn't work. These tend to get breached and they have problems related to that. The same material which we are talking of, which is coming in the form of slurry, can also come out in the form of dry powder. So out of the 80 to 100 odd thermal power stations, we have one station in which it is being handled in the dry form, and that's at Dadri. And here we are making a mound of the ash. So this is the ash, it is coming on a conveyor belt. It comes on this belt, this conveyor belt goes up like this, and then it falls, and here it will form a conical heap. And this height is about 15 meters. So this boom spreader will spread this 15 meters high. And just so that you get the idea, this is us, people who are 2 meters high. So definitely this is about 15 meters high. And that's the conveyor belt on which the ash comes. So the ash is not coming in the form of a slurry pipeline, it's not coming on trucks, it's coming on a conveyor belt. The question you would like to ask is, what happens when it's raining? Because the conveyor belt is not covered. So if you have fine powder and it starts to rain very heavily, what will happen? It will start to get washed away to the sides. So you have to take many adequate measures. What happens once the mound has been completed? This is supposed to be a 50-meter high mound. Then you can grow grass on it by putting some soil cover and give it a green look. All the visitors go here for a very nice green look of the ash mound. But I'd like to remind you that a person walked into my office several years ago and he said, "Sir, I've come from this place. Can you tell me what to do about this?" So this is also, I don't know what this is. This is also some powder which looks very much like the mound that we have got. the Dadri, it's also powdery. This is the old thing where they have done vegetation. This is the new waste being deposited. And you can see some failures. So he said, "Ye chalk hai." Maine kaha, "Acha chalk hoga." But what happens when it rains? So it looks so simple, it looks so easy to deal with. And when it rains more, so these fine particles start to move with water, and once they move with water, they'll come down the mound. And here this gentleman who had come was from some village, so this water was coming down and it was going into the village. So issue is, fine particles are very erodible. You want to contain them again, you have to give them a proper cover with proper vegetation. Otherwise, they are prone to erosion by water. So most of the fine powdery wastes which can be transported in the form of a slurry are transported in the form of a slurry. It's only the larger heterogeneous wastes which come to you in the form of a truck. So I've just opened a new world about slurry wastes for you. We have to design these waste disposal facilities so that they remain and they perform without affecting the people around it. And the real challenge is that because they are in the form of slurry, if there is a breach, they flow out. Now that kind of problem doesn't exist in the landfills that we are dealing with. If I have a municipal solid waste landfill, it will breach, it will come down by 10, 15, 20 meters. It will not travel for a kilometer. But many slurry ponds have breached where the ash has gone down a few kilometers, like water. No, it's like a pond has breached, and then it has affected human beings and houses on the downstream side. So the challenges here are, how to design a system since it is slurry waste. It has to be deposited between embankments so that it doesn't flow out. But the larger challenge is nobody wants to design to the full height in one go, because suppose my design life of my mine is 25 to 30 years and I make an embankment which is required for 25 to 30 years, it's a lot of investment to build it right in the beginning because it's going to fill up slowly. So what happens is we make embankments which will last for about 5 to 6 years, make that investment and then raise the height of this embankment. So this is very different from a dam design. In dam designs we make the embankment in one go, whether it is the Beas Dam or the Ramganga Dam, they're 100 meters high. In one go, in a year, 6 months to a year, we'll make the dam. Here, we have to either do this and go up. When this fills up, this is called the upstream method, or you will use a method called the downstream method when this fills up. And so there are different methods, but this is called incremental raising of embankments. So this design is something new. So for slurry deposited waste, an important thing is incremental raising. So over the next few lectures, we are going to first study what